Okay, so we're going to look at several different pieces. So we need to be able to both construct diagrams and interpret diagrams. And in order to interpret diagrams, we need to make sure that we understand all the pieces of a diagram and what they all are. Okay, so that's just kind of be the main point of what we're doing here, and then we'll actually get into doing the diagrams. Okay, so a point. I'm not going to get into like the hard and heavy definitions of stuff. A point in our diagrams is just literally going to look like a dot. Okay. Okay, the drawing aspect of a point is very, very, very simple. Okay, it's literally just a dot or a point, and we're going to name it. So let's just name this point A. Okay. The notation is very, very easy as well. It's just point A. And then dimension, actually a point does not have any dimension to it. Okay. So that one's pretty simple. Okay. Then we get into lines and segments and rays. Okay. Do you guys know the general difference between a line and a segment? Yeah?
A line goes on forever and a segment has set endpoints.
Good. So a line goes on forever and ever and ever. Segments have 2 endpoints on either side. Okay. So let's go ahead and fill in our definition. I'm just going to do line and segment at the same time because they're very, very similar, but just a little bit different, right? So a line extends forever. And a segment is just a quote line with 2 endpoints. Okay, so a line extends forever. A segment is a line with 2 endpoints. Okay, drawings of these. So lines are obviously going to have arrows on them displaying that it goes on forever. Segments are just going to end at points. So generally, lines have points on them. So they either have points on them like that, or there's just a little letter at the end naming the line. Okay. So we can name this line in 2 different ways. Okay, we can either call this line L, actually 3 different ways, I guess. So we have line L based on the name out beside it, or we can call it AB with a line notation on top, or we can flip that around and do BA with the line notation on top. Because since it extends forever in both directions, it doesn't matter if you write AB or BA. Okay? And then this line is first dimensional, or one dimensional, I guess. Okay, then segments are really, really similar. They just don't have the arrows. So if I draw this segment A, B, I name it very, very similar, except I'm not saying line, I'm saying segment, right? Oh. Yeah, I guess I should put this in there. Generally, see how we have this L out here for a line? That's generally not there with a segment, okay? So it kind of limits our ways we can name it. So we say AB with just a segment over the top, right? Now we're not putting the arrows on there. Or again, since it has 2 endpoints, it doesn't matter which order you do. So BA with my segment over the top. And again, it's first dimensional. Okay, so we know the difference between a line and a segment. So let's throw ray in there. So do you guys know the difference between a segment and a ray? Take a quick 30 seconds to talk to your groups. What's the difference between a segment and a ray and a line? Okay, so what do you guys think for ray? So line extends forever. Segments have 2 endpoints. What about a ray? Yep.
It has 1 endpoint and it extends forever the other way.
Good. So we're just going to say it's a line with 1 endpoint, right? Okay, so this is a line with one endpoint. Okay, the notation for this has to be a little bit more specific. Okay, with lines and segments, they either went on in both directions forever or they ended on both ends. Okay, with array, we have to be a little more specific. So when we name this ray, we're going to call it AB with the ray on top. You have to make sure when you're putting your ray notation above AB, the endpoint is where the endpoint should be, and the go on forever end is where the arrow should be. Okay, so you might put yourself a little note in here that this is not BA, right? Because on lines and segments we were able to flip-flop it around, not on arrays. Does that make sense why? Okay, because B is not the endpoint, B is the go on forever. Okay, and again, it's first dimensional. Okay, planes. So planes is where we finally take it to 2 dimensions, okay? So instead of just extending on forever and ever and ever, think about now looking at like a wall or a floor, right? So walls extend sideways and up and down. Same with floors, right? So they extend sideways and up and down. That's why it's 2-dimensional. So that's kind of our simple definition for a plane. We're going to just say it looks like a wall or floor. The most common way you will see a plane drawn, okay, is like a crooked rectangle or a crooked square. Okay, and then on that plane, generally, you will see it either named up in the corner, so we'll call this plane M, or you will see several points on there. So let's put some points on there, A, B, and C. So then a couple different ways we can name this. We can either call it, oops, I don't want to do that. We can either call it plane M, or we can call it plane ABC. Okay, so let's pay attention to something really quick. When we're naming lines or segments or rays, you use at least 2 points, right? Or the general name for a line. When you're looking at planes, you have to name them with at least 3 points, okay? Because think about it, if I only name 2 points, I'm only naming something that's going through 2 points. That would be a line. Whereas if I'm naming a plane, I have to get a third point in there so I have a dimension of which way it's tilted. Okay? Because depending on where that third point is, I could be talking about this plane or this plane. Okay? Alright. So just a couple extra pieces of information based on all of these. Okay, opposite rays. So you can see down there, it says opposite rays. If point C lines on AB between A and B, then CA and CB are opposite rays. It's probably easier to look at the picture. Okay, we see the ray CA is opposite to CB. Okay, let's put a non-example over here. So let's say not those are not opposite rays. Okay, those are not opposite rays because they do not lie on the same line, right? A and B are not points that lie on the same line here. Do you get the difference? Okay, A and B have to lie on the same line for CA and CB to be opposite rays. Okay, and then I need to add a few things in here that did not make it into the notes the first time around. So let's just add these right under here. We need collinear points. Okay, collinear points is a very simple concept. It's exactly like it sounds. It'd be points on the same line. Okay, so collinear points are points on the same line. And then we have a second one that's very similar to that, coplanar points. There they are. And just like it sounds, what would you guess for coplanar points? Yeah, points in the same plane. Okay, so pretty easy concepts there. Collinear points, points on the same line. Coplanar points, points in the same plane. Okay, let's talk about intersections. Okay, so let's talk about intersections. And really, guys, all this is just building up for me to be able to say, okay, draw a line L that intersects plane M. And for you to be able to do that. Or draw co-linear points A, B, and C. And you'll be able to do that. Or look at a diagram and be able to say, what are the collinear points? Well, the collinear points are A, B, C. You need to be able to use geometric notation, and you need to be able to read geometric notation. Okay? So that's what this is kind of leading to. Okay? So let's look at what different intersections look like. They're really pretty simple. Okay, a line intersecting a line. Just exactly what you would think it looks like. A line intersecting a line. And we'll just say it crosses it, X. Let's name the lines M and N. Would it be okay for me to write this with no arrows on the end? I see a lot of you shaking your head no. Why not? Yeah, then it'd be a segment, right? So if I don't put arrows on the end, then it's a segment. I want a line intersecting a line. So if I said line intersecting a segment, one of them would not have arrows, one of them would, okay? All right, how about a line intersecting a plane? So generally it's easiest to draw the plane first. And I promise you'll get better at drawing planes. Mine still are not ever very pretty, but we roll with it. Okay, and the interesting part about a plane is there's an in front of a plane and behind a plane, right? So as I'm drawing this intersection, I want to draw, this would be the line coming out the top, and the line going out the bottom is going to have to be dotted, because the line down at the bottom has to show that that's hiding in behind the plane. Okay, so I want you guys to all do this. Take your hand and just hold it up flat. Doesn't matter which hand. Hold it up flat. Now I want you to just stick one finger, that's representing the line, in between a couple of your other fingers. Okay, and if you point it towards you and look at it, I know it's not perfect, right? But if you point it towards you and look at it, you can see that you can see part of the line and you can't see part of the line, right? You can see part of your finger and you can't see part of your finger. That part that we can't see is that dotted part. Okay, that's why in notation we put the dots in there. Okay, does that make some sense? Okay, all right, let's do plane intersecting plane. This is the hardest one to draw. So for plane intersecting plane, it's generally easiest to draw the first one straight rather than crooked. Okay, so I'm going to call this M. And then the second one is going to be crooked. So let's do, it comes up here, over, and back down. Ooh, that is not pretty. I'm going to try again. Up, over, back down. That's a little bit better. Okay, so then we need to go, so then it's going to be dotted, right? So that's all the in front part. This is going to be dotted and dotted. And then it's going to emerge over here. And then we actually need to go back. So if you want to get your eraser out and make it kind of small, we actually need to go back and put dots in this section right here, right? Because this is now behind the top plane. So I've got my eraser out, do my little dots. Not perfect, but it's, you get the picture, right? And if you need a visual for that, now take both of your hands straight, and interlock your fingers. So that's what it looks like when two planes are going to intersect, right? So if you kind of tilt your hands around, I know it's not perfect with your fingers being out, But if you kind of tilt your hand around, you can kind of see that some of it's going to be behind, some of it's going to be in front. That's kind of what you're trying to visualize. Okay? Woo! That was fun, wasn't it? Okay. All right. Any questions on intersections? Okay, let's flip over to the second page. I guess you guys just scroll, right? I want you to go ahead and do all 10 together with your groups. I think you can handle that. All 10 together with your groups. So you're going to be talking together in your groups, working through the examples, comparing answers, communicating with each other. I'll give you, oh man, we have lots of time. Okay, I'll give you some time to go ahead and work through this, and then we'll kind of reconvene when we are ready. All right, rock and roll. Okay, so we have line M or line DC. Okay, number 2, for plane M, I just need to pick 3 points. So mine's ABC, yours could be ACE, ABE, EBC, or any mixture of those. Clear as mud, right? Do you get clear? Never mind.
Yeah.
All right, anyways. Name 3 points that are collinear. That means they all have to fall in the same line. The only option there of 3 points that are all in the same line would be A, B, and C. Okay? A point that is non-collinear with those two, or not collinear with those 3, would be E, or you could say D. Right? D is not collinear with A, B, and C. Name a point that is not coplanar with A, C, and E. So if I have A, C, and E, my only other 2 options are B or D. B looks like it's on the same plane as the rest, right? So D would be my answer as not being coplanar. Okay. Let's skip down to 7. Okay, all the rays with endpoint T. So here is endpoint T, right? So I have TR. I have TS. Those 2 are opposite rays, right? TR and TS. And then I have the other 2, TP and what? TQ. Those 2 are also opposite rays. Okay? All right, now the big doozy. Okay, we want on the diagram, draw planes M and N that intersect at K. Okay, so let me get rid of this dot here. Okay, and here goes nothing. Okay, so here is one of my planes. I need them to intersect right here. Okay, so I'm going to draw my other plane out this way. I'm going to draw this one in front, so it's going to come down right here. It's again going to intersect at line K, right? And then I'm going to come back here, and then I can start doing my dots. So you see both points where it looks like it's crisscrossing. Oh, I'm pointing at my screen and not with my pointer, sorry. Both points right here where it looks like it's crisscrossing are on line K. Some of you had just one of these points. Some of you had none of the points. Okay, you got to have the crisscrosses. So then I would need to come back with my eraser and dot this up here, right? Is that the only part? Yep. I know that's hard. That was hard. Okay, it would have been easier if they would have said draw 2 intersecting planes that intersect at K, and you could draw your own line in there, right? That would have been easier. But that was a bit of a challenge. Good. Okay, so then we get into some of the constructions. We're going to do an activity here in a minute that kind of focuses around these. So this will be good. So sketch the figure as described. So AB and BC. What is AB? A segment, and BC is a ray. Okay, so I got to be careful with that. So I have point A right here, going out to point B for a segment, and then B also connects to C. It doesn't tell me if they're collinear or not, so I could make it a straight line if you wanted to. You could make that not a straight line. You could make that straight if you wanted to and make AB a segment and then BC a ray. Okay. Number 10, line K in plane M. So we got to be careful with this, okay? So here's plane M. Line K is going to come right here. So here's plane M, here's line K. I want to throw another one at you, okay? So let's do number 11. I want to keep 10 up there because it's similar. Number 11 is going to be line K intersecting plane M. Okay, so number 10 was line K in plane M. I want you to do line K intersecting plane M. Okay, so here's plane M. That's going to look the same. Okay, what is going to be my difference to show that line K is intersecting rather than lying in plane M? Yeah.
Line K would go out of the plane.
Yeah, so what do I show on my picture that will make it look like that? The dots, right? So on number 10, we just had a solid line that shows that it's lying in plane M. Okay, but if I'm intersecting, I'm going to have the dotted piece, right? And it's funny how something like that can change the whole perspective of it, but it really matters when you get down to the nitty-gritty, right? It really matters, okay? And I know that seems particular, but it matters, okay?